Hello and welcome back. This lesson I'm going to be looking at what's called the inverse function. Now, in previous lessons we've looked at function notation. So let's say we have some sort of function f of x and it can be equal to, let's say 2x plus 3. Now, if it's a one-to-one function, it means that there is only one y value for every x value and there's only one x value for every y value. So if that's the case, we can state a new function. And we use this notation, f with a little -1 at the top there of x, and we want to find what we call the inverse function. Now to do that, we look at this original equation, f of x, and we imagine if this was y equals 2x plus 3, the inverse is defined by swapping the x and y values. So for example, if we had this graph here, and we were trying to draw it, we'd say the y-intercept is at positive 3, so that is the point 0, 3 for this original equation, or the original function f. The inverse would mean that we'd swap those. That would become to the new point, which I'll do in red, at 3, 0. And the same thing for every single xy coordinate. We'd swap their place. So how can we find a rule for this inverse function? If the x and y coordinates swap, then we rewrite this equation exactly how we see it here, but we're going to swap the x and the y. So you can see what I did there from the orange to the reddy purple. We've swapped the x and the y. So now I have x equals 2y plus 3, and then we rearrange to make y the subject. So if I move the minus 3 over, I get 2x minus 3 equals 2y, divided by 2, so I get x on 2 minus 3 on 2 equals y. So this inverse I can call the function x on 2 minus 3 on 2. If I wanted to simplify it all, I could write x minus 3 on 2. Now, when we sketch that, we get a really interesting occurrence. So if we look at our CAS calculator, let's go to our graph and table and let's sketch these two equations. I'm going to sketch 2x plus 3 and hit execute. Oh, sorry, no, hit the graph button at the top there. And on the second line, I'm going to do my x minus 3, put that all over 2. And when I sketch them, I get this pattern. And you can see here, they intersect down here, but my y-intercept was at 3, the inverse has got an x-intercept at 3. This one's just before -2, that one's just above -2. Now, if we're swapping the x and y's, what you end up getting is a reflection in the line y equals x. So if we drew a 45-degree diagonal line through the origin here, these two would mirror each other. Let's look at a more complex example. Let's look at a couple graphs like this. We've got a parabola and a root graph. Now, I've put this up the top here to stress the inverse will only exist if it's a one-to-one function. To do it, we swap the x and y. Now, the process is a little bit more complicated than that, but that's the main idea of it. We're swapping x and y. So let's look at this. I think this comes from exercise 5G, question 3, C and D. So look at the top one. We've got f of x is equal to x minus 4 all squared plus 6. And you go, well, that's a parabola by itself. It's not one-to-one. So you notice in the question, we've actually restricted the domain. So we've got a domain of f. So in this case, x belongs to -infinity to 4. So when we're sketching that graph, we're only going to be having part of it, part of the parabola. So to find the inverse, imagine that f of x was a y, we'd swap it. So we'd have x equals to y minus 4 squared plus 6, and then we rearrange. So swap x and y, and then make y the subject. So when we say make the subject, we're trying to get y by itself. So I'm going to move the 6 over. I'll get x minus 6 equals y minus 4 squared, so then I'm going to have the square root of x minus 6 equals y minus 4, and then going to plus that over, so I can have y equals root x minus 6 plus the 4. Now, when we make y the subject, what we've done is we've introduced another variable. Our original function had no y's in it, so we want to swap out that for that function notation. F of x equals root x minus 6 plus 4. So let's pull up our CAS and let's sketch these two and see what they look like in comparison to each other. So let's clear what we've got. I'm going to type in that first one, which was x minus 4 all squared plus 6. And remember from our previous video, if we want to restrict the domain, we go to math 3, use a vertical line, and x is less than or equal to 4. So we can go x is less than or equal to 4. Sketch that. We see there's our half a parabola. So let's zoom out a bit. Alright, there it is. So the graph of the inverse should be a reflection in that y equals x. So we notice when we did the square root over here, we could have the positive or negative. So we've got to be careful what it would look like. That's our graph here. So we want it when it reflects to be coming down here. So pretty sure we should have a negative here. Let's check when we sketch. So on this line, I'm going to sketch the inverse. So I want to use my square root of x minus 6 and then put my plus 4 at the end. And you go, oh, that doesn't look like a reflection. So, right, let's put our negative in there. And there it goes there. Now, the last thing to look at is our domain and range. Now, we know with the original function we had a domain that x was less than 4. If we're swapping the x and y's to find the inverse, then the domain of f, which denotes all the possible x values, will become the range of the inverse, which is all the y values. And likewise, the range of the original function will become the domain of the inverse. So if we look at our original function, and we're to state the domain and range of the inverse, our original function had a domain that was x was less than 4, and so the range at x equaled 4, we can say the smallest y value would be at positive 6. So the range was 6 to infinity. So for this inverse function, we would have where x is going to be greater than 6, or we say x belongs to 6 to infinity. So if the domain of the original function was x is less than 4, then the range of that original function there is the domain of our inverse. Okay, now I don't have to worry about finding the range because it was in the original question, which is up the top there was negative infinity to positive 4. Okay, let's do one more example together. This one's not as nice originally. We've got here, now we're starting with a root graph. So let's take these instructions here. And we're going to use these again. So we're going to swap our x and y first. So let's look at our function. We've got domain of f is 0 to 1. So I know my range of my inverse is going to be 0 to 1. Okay, we're doing in reverse order to the previous one. And our possible range of f would go, well, between 0, you'd have root 1, which is 1, and 0. So you go to 0 there. So the biggest value is going to be 0 to 1 as well. So let's have a look, and our domain of our inverse should be the same. So let's have a look at our working out here. We've got, let's just let y equal 1, or root 1 minus x. That's our original function. So the first step, we swap them. So we end up getting x equals root y. Oh, stuff that up. 1 minus y. Square both sides, get rid of the root sign. So I'm going to have x squared equals 1 minus y. So I can have y equals 1 minus x squared. Right, now if we look at our original function, again on our CAS, we'll do a quick sketch. Clear all. We had square root 1 minus x, and it was between 0 to 1. So 0, and they're both square brackets, so we want the less than or equal to x, which is less than or equal to positive 1. And our second one we said was 1 minus x squared. If we have a look here, oh, what did I forget to do? Forgot to restrict my domain. So let's zoom in. That's not the one I wanted. So if I zoom all the way in there, you can see we've only got a tiny part of that graph. So we only want it, the range is from 0 to 1, and the domain was 0 to 1. So for here, we want to restrict that to 0 to 1 as well. 0 less than or equal to x, which is less than or equal to 1. Make sure we tick our graph and sketch. And we see they almost look the same, but if we get in nice and close there, we can see they're going to intersect there, y equals x. Alright, they cross over and they're reflected there. Okay, so the domain, to recap, the domain of our original function becomes the range of our inverse, and to find the range of our original function, we've got root 1 minus x, and we know it's between 0 and 1. When x is 0, you got root 1, that's going to be the highest, and then when x is 1, you've got root 0, 0. So just so happens the domain and range for these were the same. Okay, so the domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. So the final step to write our answer, remember we've got to swap out the y. So swap out the y for the function inverse notation. So we end up getting the answer is f to the negative 1 of x is equal to 1 minus x squared, and the domain, I should write f of x such that it's from 0 to 1. I was writing that out in full proper term, or you can just put it out here. X belongs to 0 to 1. Okay, I know it looked confusing at first. The more that you practice of, we just swap the x and y's, rearrange to make y the subject. The only thing to be careful of is at the start is that make sure that it is a one-to-one function you're trying to find the inverse of. Otherwise, the inverse does not exist. Okay, all the best for exercise 5G.